right. In this section, we'll discuss limits involving infinity. And for my first example, well, before I do that, these are also involving asymptotes. And those are lines that the graph gets closer and closer and closer to or approaches. And we'll see that we'll talk about horizontal and vertical asymptotes also in this section. The first, I want to graph 1 over x and look at that graph. And the graph of that looks like this. And you can see that on your calculator, or you can plot points. Now, if we take the limit as x goes to positive infinity of 1 over x, we see that as x goes to positive infinity in the blue, then the y value is getting closer to 0. The graph is getting closer to 0. So this is going to equal 0. If we take the limit as x approaches negative infinity of 1 over x, looking at the graph, here's x going to negative infinity. This way it's getting larger and larger negatively. The graph, the y values, also approach 0. This the x-axis is also called y equals 0. Okay, so this right here, y equals 0, is the horizontal asymptote, because the graph is getting closer and closer and closer to that line. And it could cross it, but in this case it's just approaching it. It's never going to get there, and it's never reaching there, but you can get as close as you want to it. So this is called a horizontal asymptote. Another way to think about that is you're doing 1 over a very large number. So 1 over a very large number, in this case it's approaching infinity, goes to a very small number. They're reciprocals. So, example, 1 over a million is this. So you see, like 1, what you should think of, you don't write this because it doesn't make any sense. Infinity is not a number. What you do is think 1 over infinity goes to 0. That's what you should think, or what should go through your mind. 1 over infinity goes to 0. And the opposite is true. 1 over a very small number is a very large number, because, again, you're taking reciprocal. Also, note, but again, I don't want to see that written. That's not something you write it. That doesn't make sense, because infinity is not a number. That's what you should think, though. Note that any time x is raised to a power and it's in the denominator, that's going to be 0. So that's an important thing to remember in this section. Okay, let's start by talking about rational functions. And rational functions, remember, have polynomials in the numerator and the denominator. So the rule here is when you take the limit at infinity, divide by x to the highest power in any of the numerators or the denominators. So this is only for when you're taking a limit as x approaches plus or minus infinity. Okay, this rule won't work any other time. So for an example, I have 3x squared plus x over x minus 2. Now in this whole problem, the highest power is 2 of x squared. So I'm going to divide everything by x squared. And that's going to be 3 plus 1 over 1 over x minus 2 over x squared. So if I want to take this limit, I divide each term, or maybe I should say that up here, divide each term by x to the highest power in the whole problem. Then that's going to be the same as the limit of 3 plus 1 over x minus 2 over x squared. But when x is very large, this goes to 0, that goes to 0, and that goes to 0. So this is going to be 3 over 0, and that does not exist. So in this case, there's no horizontal asymptote. And this is always true when the degree of the numerator is bigger than the degree of the denominator. See, the degree here is 2. This numerator is degree 2, and that's degree 1. Remember, degree is the highest power of x in the problem. Okay, try this one. What about the limit as x goes to infinity of 3x squared plus x over x squared minus 2x? Now, the highest power of x is 2, so I'm going to divide everything by x squared here again. And that's not changing the problem when you do it to each term. Okay, so when you take the limit, that goes to 0, that goes to 0, because x is getting very large in the denominator. So this is going to be 3 over 1, which is 3. So the horizontal asymptote in this problem is y equals 3. Again, this is what happens as if you graph it. As x goes to infinity, your y is coming into 3. Now, we didn't decide if it was coming in from the top or the bottom, but you can plot some points to see if it's coming in from the top or bottom. But this does tell us that there's an asymptote there. Okay, and the rule here is if the degree of the numerator is equal to the degree of the denominator, then you divide the leading coefficients. So to check that, you see the leading coefficient, they're both x squared, so they're degree 2. The leading coefficient is 3 here and 1 here, so we divide 3 by 1 and we get 3. We get the same answer. Okay, and then check the limit as x goes to infinity of 3x plus 1 over x squared minus 2x. Again, the highest power of x is x squared. Again, you only divide by the highest power of x when you're doing a limit as x approaches infinity or negative infinity. But this is what it's going to simplify to. If you divide each thing by x squared, that's 0, 0, 0. This is going to be 0 over 1, which is 0. So y equals 0 is your horizontal asymptote here. And the rule is when the degree of the numerator is less than the degree of the denominator, then y equals 0 is your horizontal asymptote, or that's the x-axis. Okay, so there's your three rules on how to find your horizontal asymptotes, or you could just take the limit as x goes to infinity. Now what about vertical asymptotes? You look oh, excuse me. You look for these where our function's undefined. So let's say here, so our function look like that. As x approaches 0 from the right, our y is going to positive infinity, and over here, as x approaches 0 from the left, our y, if you follow the graph, our y value goes to negative infinity. Again, this is the graph of 1 over x. That's what we're looking at. So this right here is a vertical asymptote. If your limit ends up being positive or minus infinity, then it's a vertical asymptote. And this is at x equals 0, or the y-axis. So if the limit as x approaches a number from the right or left is plus or minus infinity, then that means A is a vertical asymptote. X equal A is a line. Okay, so that's pretty much the definition. And again, you check where the function's undefined. Before I do that, let me make a note. A graph cannot graph cannot cross a vertical asymptote. And the reason being is, okay, if you had a graph and it crossed a vertical asymptote, then you had another graph down here, then it does not pass the vertical line test. It means for each x there's more than one y. So it's not a function. And again, it can't, here's your vertical asymptote, it can't do something like this, it curve backwards either, because again, there it's not going to pass. For each for that x right there, it has two y values. So you can't, it's not a function, we only talk about functions. But a graph can cross a horizontal asymptote. So if you have a horizontal asymptote, you can have something like this where it crosses it, but all of a sudden it's going to flatten out and approach it, or something like this maybe. Again, these aren't the only things that can happen, but it could come down and then come back up and follow it. So it can cross a horizontal asymptote. Okay, that's legal. All right, let's try an example. Let's say f of x is x minus 2 over x plus 3. Let's find the horizontal asymptote. So we take the limit as x approaches infinity, and the highest power of x is x, so we divide everything by x. So if we divide each term by x, we get x over x minus 2 over x over x plus 3 over x. That goes to 0, that goes to 0, so that's 1. So y equal 1 is our horizontal asymptote. And again, you could see that because the degrees here are equal to the degree of the numerator equals the degree of the denominator. It's both degree 1, so in that case we divide the leading coefficients. 1 over 1 is 1. Okay, so that's our horizontal. Our vertical asymptote, we're going to guess, is where x is undefined, and x equals -3 makes f of x undefined, because that makes you have 0 in the denominator, and you can't have 0 in the denominator. So that's what we're going to guess it is. And we'll check it by taking the limit. So the limit as x approaches -3 from the right, okay, here's the part that you really don't write down. This is what you think in your head, but don't write. So I have the limit as x approaches -3 from the right. Well, that makes the numerator -5. The numerator is approaching -5. Okay, and here's a number line. Here's -3. Close to -3 on the, okay, let's go from the right. On the right, that's -3 plus. Real close to it will be -2.999. Let's try that. Just pick a number really, really close to -3 because you're approaching it. So what you're thinking is, let's put that in there. And that's going to be a -5 over 0.001. Okay, so what you have is a negative number and 0 in the bottom from the positive side, and that's going to be a negative number over 0. I'll just say -5 over 0 is -infinity. When you have 0 in your denominator, one over any number over a very small number goes to a very large number because they're reciprocals. And this negative sign here and that positive sign makes this negative. So the answer to this problem is -infinity. So that is a asymptote, because here's -3, and as you're approaching it from the left, it's going to -infinity. That's what that side looks like. Okay, now the limit as you're approaching -3 from the left, okay, again, this is what you think. This is scratch paper. You think in your head. You don't write it down, but -3, I'm substituting -3 in on the top, and that's going to be -5. -3 from the left, let's go back up here and look at our number line. -3 from the left, that's going to be like -3.1111, or you could pick any number close to -3 on the left. So that says, let's just pick something close. Or -3.001. Now that's -5 over a -0.111, which is like -5 over 0 on the negative side. Now you have two negatives, and you have 0 in the denominator. Again, remember, 1 over a very small number goes to a very large number. So your answer should be what? Well, you know it's infinity, but with the two negatives, that's going to make this -infinity. Positive infinity, sorry, with the two negatives. So as you're coming in here on this picture, -3 from the left, your graph's going to positive infinity, and that makes it a vertical asymptote. So, okay, we checked either side of -3, to make sure we had an asymptote. So again, let me just get you thinking. When you see this, what you do is think, but don't write it. And you can do it as scratch paper. If you have a positive number over 0 on the positive side, that's going to go to positive infinity. If you have a negative number over 0 to the positive, that's going to go to negative infinity, because that's go on the negative side of 0. If you have a positive number and you're going to 0 from the negative side, that's going to be negative infinity. If you have a negative number and you're going from 0 on the negative side, then that's going to go to positive, because two negatives make a positive. So, for example, limit x approaches 4 from the right, 1 over x minus 4. What you do is think, it could be 10. Let's make it 10. 10 over a number bigger than 4 is 4.001, say. That's going to be 10 over 0.001, which is 10. 0 from the positive side. They're both positive, so that goes to positive infinity. Try it from the other side. Limit, so the answer is positive infinity. This is what you think, though. You don't write this. So don't write that down. That doesn't make any sense. Limit x approaches 4 from the negative side. Okay, here's again scratch work. That's going to be 10. 4 coming in from the left is going to be like 3.999. That's 10 over negative 0.001, which is like 10 over 0 from the negative side, and that's going to go to negative infinity. Again, this is what you think. My answer is the infinity, or negative infinity. Okay, but don't write that down, because that doesn't make any sense. Infinity isn't a number, so you can't really work with it as it was a number. You have to just think about it. Okay. Let me do another example that you'll see. Limit as x approaches infinity with the square root in it. Okay, what you're going to do is you're going to multiply by the conjugate. So we're going to take this, and it's a little trick that you have to remember. So I'll just call it a trick. Multiply by the conjugate, the numerator and the denominator. Now that's going to give you going to cancel. Okay, now what? Well, what's the highest power of x? Well, it's not x squared, because x squared is inside the square root. And the square root of x squared is x if x is positive, and it is. X is approaching positive infinity. So this highest power in this whole problem of x is x, because you have to take into account that square root. So we're going to divide everything by x. And to bring it inside the square root, we're going to change it back to square root of x squared. X is the square root of x squared, and x over x is 1. Okay, let's keep going. Bring that inside 1 square root, so we have x squared over x squared plus 4 over x squared plus 1. I'm just putting in all the steps so you can see it. Square root of 1 plus 4 over x squared plus 1. That goes to 0. That goes to 0. So the numerator is 0. The bottom is 0. is 1 plus 1. Square root of 1 is 1. So this is 0 over 2, which is 0. So the limit is 0. Okay, so the trick is, if you have a square root in your problem, to multiply it by the conjugate in the numerator and the denominator, because that's just 1. You're not really changing the problem. Okay, look in the sample homework problems to get more examples.